Okay, let's do a few examples here, and then I'll give you some time to try. So a car moving along a level road increased its speed uniformly from 16 meters per second to 32. That's my VI. That's my VF. In 10 seconds. That's my time. What is the car's acceleration? What is its average speed? How far did it move while accelerating? Acceleration. Which one has VI, VF, T, and A in it? The very first one. Which is really just a reworking of that acceleration equals delta V over delta T, right? And some of you will tend to sort of want to go back to and use that because you feel more comfortable.
What would be VF minus VI over T? Okay.
Yeah. 32 is equal to 16 plus A times 10 seconds, right? You might remember from grade 11, if you had me, that I prefer to write the formula, substitute the numbers, and then solve, right? I don't know what Mr. Smigowski did. I know Mrs. Gannick prefers to manipulate the formula. I tend to think that kids struggle that way, so this is the way I encourage you to do it. So I'm going to take 32 minus 16 is equal to, well, it's A times 10 or 10A. So A is equal to 32 minus 16 all over 10. 1.6 meters per second squared. See how easy it is when you got the right formula? Yeah. Now, did any of those formulas have average speed in them? So, how are you going to get average? Yeah, just add. You might even remember that one from grade 11. VI plus VF over 2. 16 plus 32 all over 2. Should be 24, I think. And the last one, how far did it move while accelerating? Now, you could do this. Pardon me? I'm going to show you two ways here. This is A. This is B. This is C. I could show you V bar equals D over T. 24 is equal to B over 10. That would work, wouldn't it? But you'll notice that it only works if I've already done B. Right? Is there another way? Yes, I could have done. I could use number 2, right? D equals BIT plus 1/2 AT squared. I'm running out of room. Initial velocity is 16 times 10 plus acceleration 1.6 times 10 squared. I'm sure you can do the math, or the arithmetic, I mean. Well, let's just have a look at that, and then I'll talk. How far would this object, is it a car? Yeah, car. How far would this car have gone if it maintained its 16 meters per second? If it didn't change its velocity. In 10 seconds, how far would it have gone if it was going at 16 meters per second in 10 seconds? Come on. How far would it have gone in 10 seconds if it was traveling at 16 meters per second?
160 meters.
160, right? This number here, it's this right here, right? This number here is how far it would have gone if it had not accelerated. This is how far it goes in addition or extra because it is accelerating, right? And so then this is the value at the end, the total of those two. How far it would have gone if it didn't accelerate, how far extra it goes if it's accelerating is equal to the displacement. Okay? Notice that this didn't require step B. Are you ready to try one on your own? Try 2A on your own here. Michael, what did you use for part A? A ball initially at rest, rolls down the hill with an acceleration of 3.3 meters per second squared. If it accelerates for 7.5 seconds, how far will it move? The initial velocity is 0. The acceleration is 3.3. And the time is 7.5. Which one? And you're asked to find how far will it move. Which one has D, V, I, A, and T in it? And I said it in that order for a reason. Initial velocity is 0. All of that disappears. It's nice. 1/2, 3.3, 7.5 squared. I quite often get kids that ask me, which part is squared? Do I have to square the 3.3? No, just the 7.5, right? In fact, your calculator should do order of operations for you. Your calculator you should be able to go 0.5 times 3.3 times 7.5 squared equals. Make sure you hit equals, because otherwise you'll probably just get 7.5 squared, and you should get 92.8 meters. Is that what you got? You were more exact. Oh, good enough for me. Give yourself a pat on the back if you got that. How far would it have moved if it had started at 4 meters per second rather than from rest?
Farther.
How much farther?
Lots. Taking the quality.
Yes. Well played. So if it had started at 4, so it's going to be 4 times 7.5 plus that whole thing from before. I get it. Did anyone go and do B on their own? How about you try number 3 on your own? Flip it over. There's 2 more to try. The acceleration in number 3 is 1.4. He started from rest, so the initial velocity is 0. What distance? We're looking for the distance, and the final velocity is 7. So which one has A, VI, D, and VF in it? The last one. VF squared equals VI squared plus 2AD. You will have to use the square root button on your calculator, so hopefully it works for you. Not from overuse or something. 7 squared is equal to 0 squared plus 2AD. Yes, 7 squared is 49. Is equal to, oops. Should have replaced the A here with a 1.4. So you should get a displacement of 17.5 meters. Did you get it? Smile and give yourself a pat on the back, or cheer, or applaud your neighbor. Okay, well, you guys go try number 4, if you haven't done so yet, and then I'll give you the answer, and then I'll give you some time to work. Which formula did you need to use here? It's at rest, so VI is equal to 0. The acceleration is 1.6, and the D is 1,600 meters, which is exactly 1 mile. What is its speed upon takeoff? So we were solving for VF. So you should have used VF squared equals VI squared plus 2AD. The initial velocity is 0, as it quite often is. 2 times 1.6 times 1,600. Make sure you take the square root for your answer, and I get 71.5 meters per second. Is that what you got?
What did you get before you started?
I have no idea. I don't have that here. 71.5 squared. What is the time required for takeoff? Now, how did you solve this one? How did you solve for T? There's a few ways. I went right to,
T squared is something I can't.
I'll come by in a second. Let's finish this.
You put squared from before or after?
It kind of depends on your calculator. So d equals VIT plus a half AT squared. My distance is 1600. My initial velocity is 0. 1/2 of my acceleration of 1.6 t squared. So 1600 divided by, what's 1/2 of 1.6? 0.8 is equal to t squared. T equals 44.7 seconds. Do you think, based on your experience, maybe some of you don't have any, but based on any experience that you might have being on planes, do you think that that is a reasonable answer?
No. Takeoff's way shorter.
Your takeoff is much shorter than 44.7 seconds, right? So of all those variables, which one do you think is out? Well, the time is, but which is the one that's causing it to be out?
It's speed or acceleration.
The initial speed is 0. Acceleration, right? Would you say that 1600 meters, 1 mile, would be a reasonable approximation for a runway?
It's not the takeoff.
I would think some may even be longer. Big ones, right?
Yeah, her numbers are big.
Would you say acceleration of 1.6 meters per second squared?
No.
Does that seem low? Yeah, the acceleration is way more. Much more. You could have done that as well too, right?
Yeah.
For the second one? No. Keelan is saying, why didn't we use VF equals VI plus AT? Right? It's a lot less, yeah, absolutely. Same answer? Yeah. Also perfectly fine. Okay, I'm going to stop talking. It's 9:55. Oh, we don't have a lot of time. The front page of that booklet is more like theory thinking problems. Okay? What I usually do is I usually say we'll check those over tomorrow, but I don't think we're going to have time. I'm not sure why that took extra long. Well, maybe I went farther than I normally do. Yeah, I don't know. Okay, so I'm going to give you a little bit of time now. As you get into the second page there, the first 9 questions or so are a little bit more grade 11-ish kind of review. Like the first 1 or 2 are pretty easy. They are, they're ranked in order of difficulty. Roman numeral 1 is easy, Roman numeral 2 is medium, Roman numeral 3 is hard. Okay? When you get to question number 10, they sort of become more what I would think of as grade 12 kind of thing. There are answers provided on the back. With your smart device, you should be able to scan that code and it should take you right to the solutions on your device. Whoa. If you want. Pretty neat, I think. Yeah. Okay, so we're going to be working through this in the next couple of days. How about I say, you don't have a lot of time, how about I say I will answer questions 1 to 4 first thing tomorrow. Okay? Shouldn't take too long. So questions 1 to 4 for tomorrow, and then we'll go from there.
Like, questions 1 to 4 on the front?
On the front, yep.
And so what is this whole thing?